Hi everybody, 11 Institute welcomes all the students of Standard 10 to the subject Science, chapter number 11, and this is video lecture number 5. In today's video lecture, we are going to study about one more phenomenon that is carried out by prism, which is dispersion. In the previous video lecture, we have discussed about refraction of light by the prism. And in today's video lecture, we will see dispersion of white light through a prism. Let us see what do we mean by dispersion. The splitting of light into its component colors is called dispersion. Splitting of light into its component colors is called dispersion. We generally know that light is colorless, or we call it as white light. We generally do not see it. But due to this phenomena, we are able to see the components of light, the splitting of light into its component colors. Such a phenomenon is known as dispersion. This is the meaning of dispersion. This is a prism. This is white light or normal light. It is incident over here. It gets refracted, but also it is split into 7 different colors. Right? And these 7 different colors come out over here. This splitting is known as dispersion. This splitting is known as dispersion. Now see, in textbook it is given what is dispersion. It is very well explained that what is dispersion. My question is why? Why dispersion occurs? Right? That is the main question, and we will have a highlight of it because it is not given in the textbook, but still I will give you a highlight. Why dispersion occurs? See, my dear friends, this is white light. It is made up of 7 colors. But traveling in a particular medium, for example, if I say that here it is the medium air, and in air, these all colors are traveling together in a single ray, and hence this is a white light. But when they are incident on a surface like this, right? Now many things matter. Which surface is this? Its thickness, how much distance is between these two lateral surfaces, everything matters. If everything is perfect, then instead of refraction, dispersion will occur. But they are quite nearer terms. Just try to understand. When the light is incident over here and it comes out in the other surface, which is glass over here, we very well know that there is change in velocity. There is change in velocity. Now, these different colors of light have different velocities. Different colors of light have different velocities. If gap between these two is more, if thickness is appropriate, then change in velocity will be non-uniform. એટલે આપણે અહીંયા પ્રિઝમ લઈ લઈએ, લાઇટ આવી રીતના આવીને રિફ્રેક્ટ થઈ જાય બટ ડિસ્પર્ઝન ન થયું. એનો મીનિંગ એમ કે નોર્મલ રિફ્રેક્શન થયું. જેટલી વેલોસિટી એક કલરની ચેન્જ થઈ એટલી જ વેલોસિટી બીજા કલરની બી ચેન્જ થઈ. અહીંયા શું થાય છે, બધા કલરની વેલોસિટી અલગ અલગ છે, તો બધાનું બેન્ડિંગ બી અલગ અલગ થશે. બધાનું બેન્ડિંગ બી અલગ અલગ રીતે થશે. બરાબર ને? જેની વેલોસિટી વધારે હશે અને જેની વેલોસિટી ઓછી હશે એનું બેન્ડિંગ બી એટલું વધુ અને ઓછું થશે. કોનું વધારે કોનું ઓછું એની અંદર આપણે અત્યારે નથી પડવાનું. બરાબર ને? બટ idea is that change in velocity is non-uniform because different colors have different velocity, and due to that they undergo bending in different manner depending upon their velocity. Velocity is more, velocity is less, concurrently the bending will be more or less. Fine, that is the idea, due to which we see that a single color light is splitted into 7 colors due to difference in their velocities of traveling in air. This is the reason behind dispersion. See, actual reason is large. it is difficult to explain at this point of time, right? Considering the syllabus that we are going through. But I am just giving you an hint that different colors have different velocity in a particular medium, and due to that they undergo bending at different levels, and they are split into 7 colors over here, which we see. Fine, I will show you a video animation also regarding this. This is the definition of dispersion. When a narrow beam of white light is allowed to fall on one of the faces of prism, narrow beam of white light allowed to fall on one of the faces of prism. The prism splits the incident white light into a band of colors. The prism splits the incident white light into a band of colors. This phenomenon is called dispersion. This is quite clear now, right? Why forget this? If you have understood, that is fine, but if you don't get why dispersion occurs, that is not of importance for now, that why dispersion occurs. But what is dispersion, that you have to learn. Dispersion simply means splitting of white light into its 7 constituent colors, right, with the help of a prism. This phenomenon is known as dispersion. The various colors that we see are violet, indigo, blue, green, yellow, orange and red, which are abbreviated as VIBGYOR. V for violet, I for indigo, B for blue, G for green, yellow, orange and red. The band of the colored components of light beam is called spectrum. This band that we see over here is known as spectrum. Fine. Band of 7 colors. This band of 7 colors is known as spectrum. Fine. This phenomenon is known as dispersion, and due to this phenomenon we get a band of 7 colors which is known as spectrum. See now, here I have shown you one more image. The topmost is the red one and the bottommost is the violet one, and you can see they are having different wavelengths. The red one is like this, right, red colored, and the violet one is like this. There is difference in their wavelength. If wavelength is different, then their speeds will be also different. We have learnt this previous year, right, in the chapter of sound. If wavelengths are different, then their wave speeds will be also different. Now let us see how this works. This is a small animation which will make many things clear. See, I hope this is clear to you. This prism splits the light into 7 colors because their velocities are different, and based upon their velocities, the red colored ray is having the least deviation, while the violet colored light is having the maximum deviation. It is deviated this much, while the red color is showing very less deviation. Right, the violet one is showing the maximum deviation and the red colored is showing the least deviation because the wavelength of red light is more, or we can say maximum out of given colors, while the wavelength of violet light is the least, or it is less. Wavelength of red one is more and wavelength of the violet one is the least. Fine, and based upon that there is change in their bending also. Fine. So different colors of light bend through different angles with respect to the incident ray as they pass through the prism. Different colors bend through different angles. The red light bends the least. We have seen this already over here. The red light bends the least, almost straight, while the violet bends the most. Red light bends the least, while the violet bends the most. Thus, the rays of color emerge along the different paths and thus become distant. Different colors are twisted or tilted or deviated at different angles, due to which we see different bands over here. બધાનું deviation અલગ અલગ છે. આ થોડુંક deviation થાય છે, આનું વધારે થાય છે, આનું વધારે થાય છે, આનું હજુ વધારે થાય છે. એટલે બધાયની અલગ અલગ એક strip આવી રીતના દેખાઈ આવે છે. We can see their distinct paths. Fine. Let it be played once again so you get a very clear idea of it. Next, I hope this is clear to you. There is no doubt in this, right? The red color is bent the least, while the violet is bent the most, because the wavelength of red light is very much more and wavelength of violet light is less. Right? Here the speed of violet light is more and speed of red light is less. Due to this, there is change in the angle of deviation also. Let us now move ahead. When a white light is incident on prism, it produces spectrum of colors. We know this. When a second prism is kept in an inverted position, second prism kept in an inverted position with respect to the first prism, the color of spectrum passes through it, colors of spectrum passes through it, and beam of white light emerges from the other side of second prism. Now this is quite a lengthy sentence. It will be very much clear with a single image over here. You can see this is the first prism, this is the white light, and we get a spectrum over here, right? This is the spectrum. Now if we keep a second prism in inverted position, right, this is first prism, this is second prism, which is kept in inverted position over here. So now this spectrum is incident. Here white light was incident, here the spectrum is incident. So when the spectrum is incident, reverse phenomenon occurs. These all colors again merge together and they will again give out the white light. This experiment shows that the white light is composed of these 7 colors. The white light is composed of 7 colors, because when white light splits, 7 colors are produced. When 7 colors come together, again white light is produced. So this experiment confirms that white light is made up of these 7 colors. I hope this image is quite clear to you. The observation made by Newton confirmed that sunlight is made up of 7 colors. Sunlight is made up of 7 colors, because when sunlight splits or white light splits, we get 7 colors, and when 7 colors are incident, we again get the white light. So this confirms that there are 7 colors, and it was confirmed by whom? Newton. નવરો હતો આ laws of motion બી આણે ગોઈતા, આ બી આણે ગોઈતું. ઠીક છે, ચલો કોઈ વાંધો નહીં. ઈ નવરો હતો એમાં આપણો શું વાત? સર આપડા ચેપ્ટર વધી ગયા ને ઈ નવરો હતો એની અંદર. ચલો, that is fine, not an issue. But I hope this is clear to you. So this was about dispersion of white light through a prism. Next topic is about rainbow. Now rainbow involves multiple things together. It involves refraction, it involves reflection, and it involves dispersion also. 3 phenomena are involved in formation of a single rainbow. See, this is a rainbow. You can see the red color is at the top and violet one is at the bottom, right? But there are some confusions also which I will arise. Fine, so nothing happens. Simply when we keep a prism over here and when light is incident, we get 7 different colors over here, right? Now instead of prism, we will be having raindrop. We will be having raindrop. The light will go inside the raindrop, it will get dispersed and it will again come out, right? So instead of prism, we will just have a raindrop, but raindrop is generally having a curvature like this, right? The bottom part is curved. So based upon that, there are small changes than in the prism, but the phenomenon is ultimately same. the way in which the prism splits the light into 7 colors. Similarly, the raindrop also splits the light into 7 colors, but they undergo total internal reflection also. Now, let us see the macroscopic image of this. What happens inside a single drop? See, this is the single drop of water. Sunlight is incident. Now we are having 7 colors over here. Now these 7 colors travel inside the bubble, but they do not come out. They get internally reflected. Actually, they should come out over here, but they get internally reflected over here due to this curvature. So there is reflection also. And now they come out from here, they undergo refraction like this. Fine, I hope this is clear to you. Many phenomena occur. Sunlight is incident. Dispersion occurs over here. Here you cannot use the word refraction. Actually, dispersion occurs or refraction occurs. That is fine. Refraction occurs. This now falls inside the drop only. Instead of coming out over here, it gets internally reflected over here. What happens is total internal reflection. Total internal reflection due to this curvature. Due to this curvature. In prism there was a lateral surface, so the ray would move out. Here there is curvature and the distance is also short. So instead of coming out, these get internally reflected, right? And then they come out over here and they get refracted. Fine, sometimes if the drop is larger, this reflection occurs 2 times also. Then we will get 2 rainbows. Fine, that is also possible. For now, we are discussing about a single rainbow. Now here is the confusion. What you see over here is red color at the top, violet at the bottom. And what I see over here is violet at the top and red at the bottom. Sir, what is this? See, this is what actually happens in one drop. And for a single drop, the violet color will be at the top and the red color will be at the bottom. But the problem is there is not only one drop, there are many drops. And you have to see the entire idea of rainbow. So for that, for now, this is correct. Red is at top and violet is at bottom. I will prove how. But what happens actually is this. This you have to understand in detail. I will explain it once again. For that, for now. We will understand why red is at top and violet is at bottom. Even if here we can see that violet is at top and red is at bottom. So in rainbow also, the violet color should be at the top and red should be at bottom, but it is not so. This is the original rainbow. But in a particular drop, this is also correct. Fine, I will explain. I will clear this doubt. But first, let us understand what actually causes the rainbow. For that, the order of colors. No matter which color is at top and which color is at bottom, but how rainbow is formed, that is of utmost importance. I will explain it once again. Fine. So I am explaining it once again in our common language. This is a raindrop. When sunlight is incident on the raindrop, it undergoes refraction or dispersion at this surface. The sunlight is split into the 7 colors. Due to this small distance and this curvature, these colors, instead of coming out over here, they get reflected. They touch this surface and bounce back. Right, and they again come out of this region and undergo refraction. So there is refraction, then reflection, and again refraction, and they come out. Fine. When they come out, we see a band of 7 colors, which we call generally as rainbow. So for rainbow, generally, if here is a cloud, here it is raining, and here suppose we are standing, then sun should be behind us. Sun should be behind us, because then and then only the sun rays will come over here, they will get internally refracted, and we can see the rainbow over here in front of our eyes like this. Right, so whenever you observe rainbow, you will feel that the sun is behind. You can never see, right, that suppose here is the rainbow and sun is behind this rainbow. Never possible. Sun will be always behind you whenever you see a rainbow. Mark this. Now, whenever you see a rainbow, this is a rainy season, you will easily get to see that. But whenever you see a rainbow, mark that the sun will be always behind you. It will be never in front of you. Now, I have created a doubt in your mouth, in your mind, sorry. I have created a doubt in your mind, right? And what the doubt is that this is the raindrop, this is the original phenomenon that occurs, and as per this phenomenon, the violet color is at top and the red color is at the bottom. But when I see the actual rainbow, the red color is at top and violet color is at bottom. Why is it so? This is the original phenomenon that occurs. Violet should be at top and red should be at bottom. But why I see an inverted rainbow over here? The answer lies here is the manner in which refraction is performed by this. In the same manner, refraction will be performed by this also. So for this one, violet is at top and red is at bottom. And for this one also, again, violet will be at the top and red one will be at the bottom. And what we see is this. We see the bottom part of this and top part of this. So we see the red at top and the violet at the bottom. I hope you have some hint. We are having a cumulative effect of all such drops. This is a single drop, only one drop. But what we see over here, the giant rainbow, is cumulative effect of refraction of all such drops. Right? For better explanation, I will show you one more image, but please, my dear friends, don't be confused. Nothing such is given in the textbook. According to the textbook, you have to just write that when sunlight from our batch is incident on the raindrop, it gets dispersed at the first surface into the seven colors. The seven colors are splitted. Then it will get total internal reflection. Then it will again come out by the refraction. And we see a band of colors, seven colors, which we call rainbow. Only this much is given in the textbook. And you have to write that much only. But as again, I always tell you that knowledge is important. Hence, I am making you understand this, that red is at top and violet is at bottom. But actually over here in a drop we get violet at the top and red at the bottom. Why this difference is there? I don't think all the teachers explained this. Almost 90% of them skip this, and some of them don't know even, right? But it is my duty to explain. I am not criticizing anybody or I am not flattering myself, but you should have this knowledge, right? In this single drop, when refraction occurs through this single drop, the violet is at top and the red is at bottom. But when I see the rainbow, red is at top and violet is at bottom. I have repeated this n number of times in this video. Now let us see the reason behind this. Why do we see so? And you will be very happy. Everything will be quite clear to you just by a simple image over here. See, here we have taken two drops. This is the first drop and this is the second drop. Here also the same phenomenon occurs. See, step by step, sunlight is incident, splitting into the seven colors, total internal reflection, and the rays come out. We see that violet color is at the top, red color is at the bottom. Simple. We have seen this over here. Violet color is at the top, red color is at the bottom. Same thing happens here with this drop also. Now if there is a second drop, same thing will happen. The phenomenon which occurred over here, same phenomenon will occur over here also. And here also we get violet over here and red at the bottom. Now many such drops are there. What we finally see is red color coming from here and violet color coming from here. So when we see this, what we feel is that red color is at the top and violet color is at the bottom and all other colors are between this. Originally, for a single drop, violet is at top, red is at bottom. But when I take many drops, what is the cumulative effect? What do I ultimately see? I see the red color at the top and the violet at the bottom. You can see the man sees rainbow, red at the top and blue at the bottom, or violet at the bottom. I hope this is now clear to you. This is a quite wide area that we are thinking of, right? Nobody goes into this much detail, but as again it is an interesting topic, so I went to. Right, so this is the information about the rainbow. Now let us just read what is given in the textbook. A rainbow is a natural spectrum appearing in the sky after a rain shower. We very well know that તે ઉનાળાના થોડા દિવસે rainbow દેખાવાનું નથી. Right? It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. Right? What happens? Dispersion of sunlight. By whom? By the tiny water droplets. A rainbow is always formed in the direction opposite to that of the sun. This also I have mentioned. Whenever you will see a rainbow, here is the rainbow, and the sun will be always behind you. Right? The rainbow will be always formed in the direction opposite to that of the sun. The water droplets act like small prisms. This also I have mentioned. Same dispersion story is there. Instead of the prism, we are having water droplets. They refract, disperse the incident sunlight, and reflect it internally. See, this also I have mentioned. Three phenomena occur. Refraction occurs, dispersion occurs, and reflection also occurs internally, total internal reflection. And finally refract it again when it comes out of the raindrop. They are refracted over here again. They are split. Fine, when they come out again. So here dispersion, total internal reflection, and again here refraction occurs. And we see a rainbow. Due to dispersion of light and internal reflection, different colors reach the observer's eye. Rainbow can also be seen on sunny day when we look at the sky through a waterfall or water fountain. This also you might have experienced many a times when you observe through a waterfall or water fountain with sun behind you or any light source behind you, you see a rainbow. આવું તમે ઘણી બધી વાર ફાઉન્ટેનના કેસમાં જોયું હશે, બરાબર ને? ઓર ક્યારેક વળી પછી તમને રમત સૂઈ ગઈ હોય નહાતા નહાતા, તો ઓલું સોપ હોય ને એના સોલ્યુશન થી આપણે ઓલું બબલ્સ બનાવીએ, પેલું મેળામાં વેચે ને જન્માષ્ટમીમાં સોપ બબલ્સ, ઓલું આમ હોય સ્ટ્રો જેવું, આમ હોય ને ઓલું આમ સ્ટ્રો જેવું હોય, પછી આ બડા રાઉન્ડ હોય, આની અંદરથી તમે આમ ફૂંક મારો તો આમ ઘણા બધા બબલ્સ, સોપ બબલ્સ બને. હવે આ સોપ બબલ્સ ને તમે લાઇટ માંથી જુઓ તો તમને એવું લાગે કે આ સોપ બબલ્સ ની અંદર કલર્ડ છે, રેનબો જેવું ફીલિંગ તમને આવે. સમજી ગયા છો તમે હવે? Right? So what are these? These are nothing but water droplets. When light passes through them, we can again have an effect of rainbow inside them. Right? Inside them. બહુ બ્રોડ પિક્ચર નહીં દેખાય કારણ કે એટમોસ્ફિયર જેવું તો સેમ રિસેમ્બલન્સ આપણી પાસે છે નહીં. સેમ વસ્તુ થાય છે જ્યારે તમે વોટરફોલ ને જોવો છો, તમારી પાછળ સન હોય. If sun is behind you and you are observing a waterfall, in that case also you can see the rainbow. એવી ઘણી બધી ઇમેજીસ તમને આરામથી ઇન્ટરનેટ પર મળી જશે. રાઈટ? સો એવું નથી કે વરસાદ આવે ત્યારે જ રેનબો દેખાય, પણ કોઈ પાણીનો સોર્સ હોય એની અંદર બી તમને રેનબો દેખાઈ શકે છે with sun behind you. I hope this much is clear to you. Now we will see one animation, right, which will make it very clear, and it will make both the things clear. It will make the dispersion by prism clear. Dispersion by prism will be clear, and also rainbow will be clear. Let us now observe this animation. See, light is passing through the prism. Fine? Light is passing through the prism. This is how a prism is placed. When you pass, see, this is the top view that we are seeing. When you pass the light, it will get dispersed into 7 components like this. Yes. This is dispersion and this is refraction. We get this band of color which is known as spectrum. This is dispersion. Fine. Now let us study about rainbow. This is sun. These are the raindrops. This is a particular raindrop. Light rays pass, and yes. See, here the light rays are incident. They get dispersed over here. What happens over here is dispersion. Right? What is this? This is sunlight. Then over here, what happens? Dispersion. Here, what happens? Total internal reflection. And they come again out over here and they undergo refraction. Now you can see what is at top. Violet is at the top, and red is at the bottom. You can see that. But this is for one drop. When many drops come together, we see the red at the top and violet at the bottom in the original rainbow. Fine, I hope this is quite clear to you. Fine, so that is the formation of rainbow. We see it like this. Fine, you can see the sun is behind us. Light rays from the sun go over here. Right, and one more thing I would like to add over here is the sun is behind us. The sun and the rainbow are in opposite directions. The light rays from the sunlight go over here and we see the rainbow in front of us. Now this is the original rainbow and you can see the red color is at the top and the violet color is at the bottom. This is the main thing that we have to understand. The broadest topic. Find red at the top and violet at the bottom for the entire rainbow, but for a single drop, when these rays come out like this, the violet is at the top and red is at the bottom. Don't forget this. This can be even asked in exam. Yes, if the paper setter is smart enough. Sure, so this image speaks all. Right? Rain, sunlight, dispersion, internal reflection, and what we ultimately get is a beautiful rainbow. Right? So yes, that is the end of the video lecture and now we shall see some question and answers. This you have to write in CW, explain the dispersion of white light by a glass prism. It is in 2 pages. So this is part 1 of 2. Pause the video, write this much, draw this image as given in our textbook itself. This is from the textbook. This is not the complete answer. Once you finish writing this much, this is the second part. This is the part 2 of 2. This will complete your answer. First part, write 3 points, and second part is 2 points and this diagram. Here, this answer will be complete. Explain dispersion of white light by the prism. Then there is next question. Explain the formation of rainbow. Fine, and this is the answer itself. Only 1 page is over here. 1 of 1. This is the image given in the textbook. Now, this image is showing that the red is at the top and violet is at the bottom. So they have shown us the final effect of rainbow. This image is showing the final effect of rainbow. So this is a single raindrop over here, but actually these are raindrops and this effect is of all the raindrops. Don't be confused. You have to write according to the textbook only. You have to write according to the textbook only that the rainbow the red appears at the top and violet at the bottom. But understand the for topic what actually happens. Because marks are temporary but knowledge is permanent. Sure, so you have to write as per the textbook only, no doubts. Fine, no doubts regarding this. That sir, here in a raindrop we are having red at the top and violet at the bottom. They have written over here raindrop, but they are talking about many raindrops and this is the final effect that they are showing. What we have seen is a for topic and we have gone individually. Fine. So these answers you have to write regarding the rainbow. So we end our video lecture over here and now we will meet again in the next video lecture. Till then, take very good care of yourselves, your family, complete your homework, right? And please maintain your CW up to date, line by line. Fine. Now we will meet again in the next video lecture and discuss about other phenomena like atmospheric refraction, twinkling of stars, etc. etc. And soon we will finish the chapter. Thank you very much for listening. Goodbye.